Hi, everyone. June 2016. Let's roll back to that day, that month, when there was the DAO hack happening, which ultimately caused a very arguable event of forking Ethereum. I wasn't. I didn't start my timer. I wasn't really a blockchain guy back then, but it really took me to the level of thinking, wow, that's a case how you manage the vulnerability. And that's a lot dictated my further career in OpenZeppelin, trying to figure out how to basically protect the open economy together with amazing folks out there, and helping other to stay safe and secure, and mostly doing this in the application layer, in the smart contracts. So for those who might not really know about what's up about us, OpenZeppelin develops smart contracts as a public goods libraries. We are famously known for Solidity and working on other fields now, on other ecosystems. We've done over like hundreds of audits by now, and all of this experience led to our actually like more software as a service platform Defender, which does the code scanning today to also detect the vulnerabilities and allows you to do the transaction management. Actually, you can get the full audit cycle inside, and it's pretty amazing for whole security cycle, including monitoring and incident response. So, famous law of Murphy, or otherwise saying if there is a probability of something going wrong, it will go wrong. At infinite time span, it will go wrong. And some proofs for that. Last year, we've seen great work by Fireblocks and hacking MPC wallets. And people say, not your keys, not your coins. Well, it's fundamentally relies us on the fact that it's not really your keys, it's just a number. Someone might know them, right? Another aggregation of cool hacking techniques in our blog. And we can see here really different categories, right? So it's like compilers, protocols, smart contracts infrastructure, and like logic. So between the contract bug and infrastructure vulnerability, which I would call that you might have like two perfectly well working contracts, no bugs inside included. However, you combine them together in some pattern, and boom, you got a vulnerable pattern. And as we are growing and maturing as ecosystem, I would say like we actually going to see more of these kind of vulnerabilities over time, where like the contract bugs are eventually like the industry matures and will become less. Another topic to outline here is that a lot of these, across all of the categories, can be classified as widespread vulnerabilities. That is, there is a multiple peer to each other agents affected by the vulnerability over some ecosystem. And well, that like lifts it to the whole next level actually when you're trying to manage this problem. So in a nutshell, like, how the management of vulnerability looks today. I'm going to talk tomorrow and what we see in the future later on, but here's like today. So we basically, most of the time we have like maybe pausable, upgradable contract, and well, if you lose your keys or your management lost your keys, their keys, then you might have like access management model as well. However, mostly like you're running around like, is it possible? Can you do the upgrade? Can you upgrade fast? Like, do DAO needs to vote for that? Are there time locks, etc.? So, and what we do is basically we set up the disclosures protocol, identify access, and when really like wake up Neo, it happens. you really dream about this magic button. But like, okay, I can just selectively disable without permission, in some kind of non-permissioned way, the vulnerability done. However, really, most of the time, the case is actually you'll have like a white hat rescue. I invite you to notice how many arrows are connected in the white hat rescue block there. And the challenges, it's time critical. Pausing contracts, you really have to evaluate, like, do you really want to pause the protocol, let's say? Well, upgradability is a very permission thing to do. And yeah, mitigation is not a standard thing. You don't have this like selective button. So widespread vulnerabilities. Another topic to cover is that, well, imagine you have some ecosystem and you have Carlos, Alice, and Bob, and they all are kind of peer to each other and they use some dependency. Now, if Carlos suddenly discovers that there is a vulnerability in their common infrastructure, it actually is very important that he has some kind of ability to do the responsible disclosure so that others in the ecosystem are not getting affected by that. And you kind of coordinate the whole ecosystem in a united manner, right? Now, the problem is that actually there is some kind of game theory behind, because most of the time, like say, if you're having similar patterns in your smart contract infrastructure with your peers, it kind of implies that maybe you are like actually competitors and you're not like that caring about them maybe even. And then also you're actually having your vulnerability yourself perhaps. So you're like maybe stressed out, you're trying to do the media post, and you might do something like that. You might go and make a media post on social media before the provider or ecosystem, which is here, like manages the whole thing and helps the ecosystem to solve it together. Now, the moment you do any of these red arrows, Alice and Bob, they are not happy at all. Because now every hacker out there knows there is a problem and perhaps even can see how to replicate that attack. So that being said, it's really important to incentivize from the ecosystem the need for the responsible disclosures. So there can be like multiple ways to do that, but basic one is just, you know, we're a community and we're workers community, and that's great. It's actually, I think this is like, this makes a lot in the security. So having a community code of conduct and using it smart in a wise way. Let's say, you know, so many ecosystems today, they allocate the grants to their participants, but well, you know, if you have, let's say, if you package the audits in the grant, you're actually building the auditor expert field for your particular ecosystem, for the particular notion there must be there. And when, you know, it hits the fan, that problems happen, you actually have a really like wide notion about the ecosystem on some team of auditors who can actually step in and, you know, help out solving things. And you need to support in the media, and you need to step in when it's needed. And all of this is quite critical. And it comes into like, you know, defining your ecosystem emergency protocol, basically. What do you do? What happens? Because from previous slide, Carlos, he needs help at that moment, and everybody do. And the ecosystem is the level where you actually solve that. It's a step above them. Well, one practical example is recent vulnerability management we did with ERC 2771 when combined with multi-call contracts. So for those who are not really aware how did it work, that basically if you do the multi-call through the trusted forwarder, and you're basically can get this UML diagram. And oopsie. And what it allows you actually, it allows you to like do the spoofing and execute whatever you want from the victim's contract. So for our case, you know, like that was a like first step we had to do is assess, assure, and work out and understand what's actually happening. We also at that point, we already had to do some acknowledgement to the community. The next step we did is actually we set up the monitoring and triaging in Defender. So you could actually go to the Defender, scan your contracts repository. We added quickly the ability to scan for that particular vulnerability, and you could see if you are affected or not. And that moment, of course, already the disclosures had to be made as well, and explain how to do the vulnerability management for ecosystem. The time was ticking, and we were communicating with some initiatives like SEALS and Security Alliance to help as much affected projects out there as possible. That being said, like, okay, this is what happens today. It's not perfect, we know that, and it's actually quite tricky to manage. And even in the previous example, there was funds lost on some projects, not super a lot, but it's something we want to minimize. Remembering that there was like some time before, like 2016, we did like a hard forks, and today we are like kind of like learning how to mitigate. But you know, what's tomorrow? How do we get to the level we want to be like safe and secure for our users? So I really like this example with airplane and engine fire. Basically, you have to have a checklist for everything, right? But what I really like even more, and actually I have a lot of background in the more traditional industry, so I kind of know and read a lot of standards in my life. So you know why the cars really work well for like 10 years, and you can actually drive and sometimes even release your steering wheel and trust it's not gonna fail. Why does it work? How does it do that, right? So the answer is standards. They have a lot of standards. So you see the Ford, GM, Chrysler, and this is just like, you know, European American companies. They have a lot of standards. They're, if we take a look, these standards are actually being written by most of non-profit organizations, which are collaborations between the industry experts in all of that fields, including like, you know, even like doing the audit and management systems through the ISO. And that's not it. It gets like really bigger, because like you take like one standard for component reliability, and this is like, you know, how big it is. Each box here, it's some separate test with like book to read about, really. And we don't really have that, right? What we have is something like this, and this is what we're like really relying on, the two main pillars today, from which we are hopefully are growing to the mature industry and mature standards set, which will allow users to feel safe. Two of those are community principles. And you know, the bug bounties, Immunify, it works great because there are some community principles. And actually, like even like most of the disclosures, they do happen actually in quite responsible manner. People do like approach us even if they're not directly our client asking for help, because they want to do the best for the ecosystem. Because truth is that most of the people are really kind, nice people out here. Like this is why we're all together, and I really enjoy speaking to you here, because I truly believe in the you know, good sparkle inside everyone. And then there is also like, you know, if you take a think about like regulatory frameworks and like funds recovery and like, you know, let's say criminal and law systems, they are actually some kind of social rating systems. So it's just a matter of, we would probably find a lot of use if we would put more of this on chain. And it seems that we're going in that way, actually. Now, the smart contract security, it's really something that still is evolving a lot. And account abstraction changes things, mainly because not because we are getting like transaction batching or paymasters, but rather because we are getting this kind of consensus in our society about that smart wallets are the way to go, really. Like, you might use Gnosis, or you might use DAO, or you might use some new emerging smart wallets, but it's the way really to go and store your funds on account abstracted wallet, the software wallet, basically. And you can do a lot of things there. Like, one of the really like getting exciting for me is that you actually can make more user-centric asset ownership models, which will ensure more safety and security for the end user. And you can actually plan for disabling vulnerabilities, and you can actually build the whole apps and infrastructure registries. Some of that, right? So one thing with like previous example of address spoofing via meta-transactions was that there was no particular responsible authentication and authorization layers. And people do like really miss that point, that these are two different things. You might want to understand who is sending the message first, and then you might want to understand, is this person authorized to do that? And the classical security in Web 2 as well, like it's well-known things that you do that. And you have the intrusion prevention systems, which, as today we have a lot of conversations about blobs and gas prices going down for L2s. It means we can put more logic for security on chain. Any method can be anticipated as point of failure. Basically, you can wrap your logic, proxy contracts are already doing that. Basically, you have a fallback which sends you to the logic, which acts as a wrapper for your state. Now, the same way you can do another wrapper there and do like authorization. You can do another wrapper, which is like authentication. And you can do the third, and you can do a lot, as much as you need. And this allows actually to self-sovereign these layers of security and preserve non-permission ethos of crypto space by basically saying, okay, I need like this is layers to secure my ecosystem, and they can be totally orthogonal to each other in terms of who is actually managing which layer and how they are actually decentralized. So secure apps. So this is a very simple model, like which we use today, actually. Like, so if you have a DApp, you have an asset, you have a user will try to do something with a DApp, right? And he will have to approve the asset, and the DApp will start calling transfer from on behalf of the user, right? But there is something missing, and something very important. Like when you're doing, like say you went for Uniswap, first time in your life, or your grandma. What will your grandma do? She will ask you probably, like, is it safe to use, right? So you're a trusted entity. And the DApp actually is going to do the same. If it's a decent DApp, it has to do the QIC, actually. Or at least QIT or something to check. Like in recording the previous slide, maybe do the intrusion prevention detection, something-ish, right? And we could actually, put this on chain. And if we put this on chain, we are actually automatically on chain already saying by Oracle which app is secure, which app is not. Once we do this, we actually are able to do the automation cycles inside on the chain based on some metrics as well. So kind of gets amazing from there. But right now, the trusted entities are mostly the the physical or off-chain data. Yeah, another thing looking into the future is more like user-centric models. So, you know, virtual machine is just another, EVM is just like another virtual machine. Virtual machine is just machine. It's based on some same principles. And if we recall like how the operational system works, right? They have they operate on machine. And if you imagine, like, say you're a user and you have a door, and the door stores some asset, and the door is Wi-Fi controlled. So the person who has control to that Wi-Fi module on your computer, we can say he has pretty much control over the asset. But if you install some app, even if you use it, it doesn't necessarily mean that that app has direct access to that module. There will be an operational system which will manage the permissions. And well, if we have software wallets, which I call an age of account abstraction, then we can actually treat them as operational system which manages API permissions to external apps. And that allows us actually to, even if we drop that app inside of the secure registry and we have secure apps in that registry, we already at that point can assume that all of the apps in the registry have a same trust assumption between them, which means they are, like, let's say, you cannot randomly upgrade it, perhaps, but inside of that ecosystem, we are quite sure that wallet cannot do like something on their, like arbitrary. It will have a very deterministic API, which apps can trust as well. And well, this allows us to build security models, you know, where you could actually split assets from ERC-defined interfaces. Say ERC-20 doesn't define you how you store the data about the assets. It just defines you the interface. You don't necessarily need to use the same contract. It's up to the implementation, which can be changed. And then if your user wallet becomes acting as operational system, then it can actually talk to the secure apps registry and could I even like basically query for like, you know, I want to install a DeFi DApp. What's up with that? Like, which one is good? And it can go like up to the implementation for the applications as well, where, you know, you want to preserve observability. That's fine, that's great. We have IP 712. And there is like this versioning. You can actually, in the apps registry, you can figure out and doing the semantic versioning, right? Very familiar thing. Why don't we do that? And yeah, an amazing thing about that is also you can actually set up a lot of circuit breakers in a different trust flow. And that would allow you to actually really narrow down any vulnerability to particular block, particular onion of security, which you can disable. Yeah. So that's quite it. I think we have some time. If there is any questions, I'm happy to answer. And otherwise, feel free to reach out if you have any questions.
Any questions from the audience?
Hi, thank you for the talk. And I was wondering that, because you have mentioned that to detect the vulnerability is a like important part, or because I'm a developer, so when my contract might be at risk, and there are always more hacks or more vulnerability we discover. But what are the practices that might enable us to detect the vulnerability instead of monitoring what is happened already? Is there something that we can do instead of just monitoring?
Practices for detecting.
Yeah.
Set up the monitoring. And to do that correctly, frankly, you have to early define the requirements and criteria for efficient monitoring system. So, for example, let's say you're operating the bridge, which does like mint burn operations. It's actually quite tricky to monitor for invariant state across chain. So defining early like what kind of events and what kind of structure for good monitoring you need for like reading data off chain today is useful. And then installing monitoring over the like expected state operation, so expected flow of data, expected value changes, and also we have a Forto network, which is a spin-off from OpenZeppelin. It's a decentralized monitoring system where you can actually enable AI attack detection. It shows it's an AI model, so it can like do the false positives, but it shows a lot of results when it sees real attacks happening before they actually happen.
Yeah, I've like heard about Forta, and they mentioned that maybe some hacks happen. There will be some steps before it happens, so they will have a monitoring system to do that, to maybe predict that something bad is going to happen. I'm just wondering that like because OpenZeppelin got the Defender, so it enables us to do the management and also some monitoring. And you also mentioned that when there's already a hack happen and you can scan, like retrieve some, I don't know, signature or something that you can know that if your contract also has the same vulnerability. I was wondering that if this is already integrated in your system or you have other plans.
So in case of Code Inspector, which is our scanner tool, the way it works is that you integrate it to the GitHub, and it creates reports on your GitHub, usually on the PRs. And in a case which I've shown, what happened is that the moment we saw this happening, we started adding the new check, because in Code Inspector there are two fields. Basically, we have static rule, like set of rules, and we have an AI model. So for that particular case, we added like just a rule which was checking, and that was a manual step we had to do because the AI model yet didn't see that.
So that would be a like source code level or a bytecode level?
It's a source code. So you just plug it into the GitHub repository.
Thank you.
Any more questions?
Well, first of all, awesome presentation. I love how you turn the that incident and then like come up with the framework. That is really lovely. I work for QuantStem, and I actually like when you guys are doing the investigation. We in parallel also did, and it was like very fun. And I think there's one thing that was very challenging, and like would love to pick your brain on how you guys like approached it, because how we did it was like basically looking at our clients' code, etc., and scan proactively. But then there's the aspect that I absolutely love about your thing is that the community security thing, right? How do we reach out? That is something really hard, and I'm wondering at the time. I know that you guys have acknowledged it. I think we sort of. I think there was a previous Twitter post from the other one was first acknowledged, and from there we sort of like deduced, and then you guys like announced almost at the same time. We figured it out, and we're like, okay. But I was wondering whether like I don't know, like what's the step or what's your experience or learning from that? Because that was a very, very nice, not nice incident, sorry, but very interesting incident. And I love how you guys handle it as well.
Yeah, that's a good question indeed. So the reason why we also posted acknowledgement early was because there was this another post, and it actually started the race. It was a panic, so we had to like make some reassurance for the community. And then the management part was actually part of this you saw on the slides where we actually were doing the post messages and trying to coordinate community-wide. But also there was a lot of work happening just in Telegram, just reaching out people, just finding their contacts, just checking like manually like repos, like who can be affected in this. And this is why I also mentioned the ecosystem emergency protocol, because I see as a real need to have a protocoled version of doing that. And this is not something that projects can do themselves. They can do the threat modeling, they can do incident response drills, which like we do the projects, but if they are affected by something that happens from the higher level, it has to be managed through that protocol there.
Absolutely lovely. Thank you so much.
Thank you. All right. And great, thank you for having me here. Really enjoyed that.